All right, section 3.3, this is measures of precision. I'm in the learn section. There's quite a list of things that we want to be able to do. So we're going to walk you through how to do each of these. Some of them you already know how to do. Some of the positions as far as percentiles are a little bit tough to understand the definition, but I'll do my best to explain it to you so that it's clear. And then we'll do a few examples in Hawks. Okay, so percentile definition is important. Okay, these divide the data into parts. Okay, so if you divide it into 10 parts, it's called deciles. Not that important, but you just need to know that percentile divides it into 100 parts, because it's 100%. Let me see. There was a definition part that I wanted to point out about percentiles. I didn't see it. So this is the directions for finding the 10th percentile. If I want to find the 10th, the 20th, 30th, 50th, whatever. So this is telling you the location of that. Says the 10th percentile is given by this. L is the location of the 10th percentile when you put all your numbers in order, so ordered array. N is the number of data values you have, and P stands for the percentile over 100. When you use this formula, we are going to want to get a decimal. So if you do this, you take, let's say it was 20% divided by 100. So you'll get 0.2. You multiply that by n, however many values you have. So you got 15 numbers. If this number right here results in a decimal, that's what number 1 is saying, then you're always going to round up, okay? Doesn't matter what it is. So if I do this formula, okay, and I get that L equals 1.02, okay, I know that this number does not round up, but the formula says you always round up to the next largest number. So you're going to round this number up to 2. So this is saying the second number, when they're in order, is going to represent that percentile, okay? So this is what they mean, always round up. So if you get a decimal, you round up. Now, if you use this formula and it comes out to be a whole number, okay, that's problematic. We don't want whole numbers. Usually, you do want whole numbers. In this case, when you're finding the location of a percentile, it would be better to have a decimal. But it says if you get a whole number, the percentile is the mean of the data value in that location and the next largest. Okay, so what that's saying, if I do this formula, and it comes out that, say, L is equal to 5, okay. So just like if we were to find the median, I would need to find the 5th and the 6th number, add them up, and divide by 2. So if I had some numbers like 10, 11, 16, 20, 24, 38, 40, so on. Okay, 1, 2, 3, 4, 5. The 5th number is 24. The 6th number is 38. You would have to add 24 and 38 and divide by 2. And let's say that's 50, 62. So we would get 31. So this would not tell you the location. This would say that 31 is the percentile. Okay, that would be the percentile of that value. So it's telling you what the percentile is, not the location. Okay. So this is the formula for location. It tells you the location if you have a decimal. If it results in a whole number, then the percentile value. Okay, it's telling you the value of the percentile, and this one is the location. So it really want to tell you the location. What I was looking for is some books are a little bit different. So sometimes L, they count L as the I guess it's more important than other formulas, so I'll talk about it there. But this is how you find the location. This is tough to deal with. This is one of the ones I was mentioning. It's going to be kind of tough, but as you do it, you'll understand. So pay close attention to these two circumstances here, whether you get a decimal or a whole number. So here's an example. Now, stem and leaf chart. We might have seen this in chapter 2. The 12 is the first part of the number, and 1 is the leaf. So this number is 121, 133, 141. We got 155 and 156. So you have 161 twice. So usually there's some kind of key. Yeah, actually it's 12.1. So this is the key, and we want to know what the 10th and 20th percentile is. Well, you would do the location formula when they give you a value. So we'll talk about how to use this. I'll show you some examples of my own. You can also see the ones in Hall. Now this is the other one that's going to take some time to use. This is the location. So given a value, so let me go back here. Say these were my numbers. I want to know what percentile does this number represent. So we'll use this formula now. They're not telling us percentile, we're finding the percentile. So here's the formula. If you did algebra with the other formula, it's the same. P equals L divided by N over 100. P is the percentile. That's what we're looking for. L is the number of values in the data set less than or equal to. So this is what I was trying to find. Some books, and it should be the same, would say that L is just the number of values that's below it. And this book is saying equal to. So how many numbers? There's 1, 2, 3. There's 3 numbers here. So percentiles basically tell you how many numbers are at or below that value. How many are below you, basically. So we're going to use the percentile value. So let's just say, for example, this was my data set. I have 1, 2, 3, 4, 5, 6, 7 numbers. So N would be equal to 7. I want to know the percentile value of this third one. Okay. So P, as that formula, would be equal to 3, 1, 2, 3, divided by 7 times 100. Okay. And there's no special case here. Whenever you do this, you're going to round to the nearest whole number. Okay, so if I pulled up the calculator and we did 3 divided by 7 and then times 100, we would get 42. We would round it up to 43. So this number would represent the 43rd percentile. So 43% of the data are at or below this number. Percentile tells you how much is below you. Okay. So that's the 2 big formulas you're going to be using here. Okay. How to give some examples. Okay. Showing you how to use it. We'll do some more in Hall ourselves when we start doing the practice problem. Okay, quartiles. Divide your data into 4 pieces. The minimum to the first quartile, the first quartile to the second quartile, which is also the median, the second quartile to the third, and then the third to the end. So there's only 3 quarters, but it breaks it down into 4 sections. Okay, 1, 2, 3, 4. This is easy to do by hand, but we're going to let the calculator do it for us. If you wanted to find it by hand, what you would do is put all your data in order, smallest to largest, find the median, and I believe you do not use the median, no matter what, whether it's in your data set or not. So your median will cut it in half, and then you find the median of the first half, which is Q1, find the median of the second half, that's Q3, and that gives you your quartile. However, we're going to do it in the calculator. Easy enough to do by hand. So they're just showing you some examples. These quartiles are very important when we're dealing with the 5-number summary. So here's the 5-number summary. We're going to talk about how to make a box plot with this. 5-number summary is your smallest value, minimum, Q1, Q2, median, Q3, and maximum. So all of these are just basically medians. This is the true median. This is the median of the first half, median of the second half, and your smallest and largest numbers. When we do the 5-number summary and you make a box plot, you just do it on the number line. Okay? The smallest value would represent your minimum, so that would be the first ticker on your box plot, which they call a whisker sometimes. Then the first line of the box will be your Q1. Second line of your box would be the median. And the end of your box will be Q3. So you make a box out of those. That's why they call it a box plot. And then your last, very end, is your maximum value. We haven't done a whole lot with interquartile range, but in case it pops up, okay, interquartile range is just the difference between Q3 and Q1. Okay, we're probably not going to be using it very much, but just in case, it's the middle 50%. Just the spread between your middle 50. This is important in some upper level sections because the interquartile range is not affected by outliers. So if you have something that's really, really big or really, really small, the middle of the data is not really affected by those big numbers. So here are several box plots side by side. I'm also going to show you how to do a box plot in the calculator as well. So here's some directions for doing so. If you're drawing it out. Some more examples in HOG. And the last thing we need to see is z-score. Standard score, z-score, both of those are the same. Okay, so that is something that you might want to write. Standard score, z-score. This is very closely related to the bell curve. We'll be using this again. So we did this in 3.2. We're going to be doing it again. So we're going to be using z-score to estimate percentages on this thing much later. But right now you're getting an introduction to it. So here's the formula for z-score. X, so some data value minus the mean divided by standard deviation. This is for population. And you have one for samples. Same calculation, a data value minus the mean, which is sample mean, divided by standard deviation. Okay, z-score tells you how many standard deviations you are above the mean. Okay, so approximately. So here it is. Z-score tells you how far above the mean. So specifically, how many standard deviations from the mean you are. So that's what z-score is. You need to know what it is, what it does, what it tells you. It tells you how far above the mean or below the mean you are. Again, this is the type of things that allows us to compare apples and oranges. Finding the z-score. If I have two sets of data, I can do z-score and I'll be able to compare those two. Every time you do z-score, very important here, round to 2 decimal places. Okay, always do that. That's going to be important there. And then you have some examples for finding z-score, which we'll do several of those in HOG. And then here is the directions for finding and making a box plot in the calculator, which we will do that, and I'll show you how to do that as well. Here's some other functions that they will allow you to do. These I haven't really used because I can do everything that we need without them, but if you use Excel, you can do these in Excel. But I'm going to show you with the calculator. And then you can do this in Minitab. So there's a lot of programs that can help you do this. Okay, let's go to HOG.